going to discuss subtracting rational expressions. Under this topic, we have to tackle subtracting rational expressions with the same denominators, subtracting rational expressions with different denominators that cannot be factored, subtracting rational expressions with different denominators that can be factored.
But before that, we have to tell you our objective. Number 1. Subtract rational expressions with the same denominator. Number 2. Subtract rational expressions with different denominators.
Our essential question is, how do you subtract rational expression with the same denominators and different denominators?
With that said, let's start with subtracting rational expressions that have the same denominators. Here, we have the steps. Step 1. Subtract the numerators. Step 2. Retain the common denominator. And Step 3. Simplify the result. We're going to give you an example. So here, we have 25 over 3x minus 5 subtracted to 9 over 3x minus 5. First, let's subtract the numerators. Remember, we have to apply the rule of integers in doing so. In subtracting integers, we have to change the operation to addition, then change the sign of the subtrahend to the opposite sign it has. 9 is the subtrahend, and given 9 is positive, we have to change it to the opposite sign, which is negative. So if we rewrite that, we'd have 25 over 3x minus 5 plus negative 9 over 3x minus 5. Because 25 and negative 9 have opposite signs, we'd have to subtract them. 25 minus 9 is equals to 16. That leaves the numerator with 16. Then we move on to the next step, which is retaining the common denominator. As you can see, both of these rational expressions have the same denominator, so we'd have to write the both of them as 1. We'd have 3x minus 5 as the denominator of the difference. So if we combine the numerator and the denominator, we'd have the answer 16 over 3x minus 5. The last step is simplification, but since 16 over 3x minus 5 cannot be simplified, that is already the final answer.
To test if you understood the lesson, pause this video and try answering this equation. We'll show you the answer by the end of the video.
Let's move on to subtracting rational expressions with denominators that cannot be factored. Here are the steps in finding the difference. First, find the LCD or the least common denominator. Second, divide the LCD with the denominator. And third, multiply the quotient to the numerator. And fourth, subtract the numerators and keep the LCD. And the last step, simplify if possible. Here's an example on how to solve rational expressions with different bases that cannot be factored. The given is 2 over 3a subtracted to 4 over 4b. First, we find the LCD of 3a and 4b. In finding the LCD, we have to list down the factors of each denominator and align the same factors. 3a is equals to 1, 3, and a, and 4b is equals to 2, 2, and b. Then we bring down the factors 1, 3a, 2, 2b. And multiply them. Its product is 12ab, and that makes 12ab the LCD. Second, divide the LCD to the denominators. So we'll divide 12ab to the minuend's denominator, which is 3a. 12ab divided by 3a is equals to 4b. Then we do the same to the subtrahend's denominator. 12ab divided by 4b is equals to 3a. Third, we multiply the quotient we got to the numerators. Therefore, we'll multiply 4b to its numerator too, and then we get 8b. We do the same to the subtrahend. 3a multiplied to 4 would have the product 12a. (8b minus 12a over 12ab). Fourth, we subtract the numerators and keep the LCD. Since the rational expression doesn't have like terms, we can't subtract them, so it'll remain the same. And lastly, simplify if possible. 8b minus 12a over 12ab cannot be simplified, therefore it is the final answer.
To test if you understood the lesson, pause this video and try answering this equation. We'll show you the answer by the end of the video.
We'll discuss factoring rational expressions with different denominators that can be factored. Here are the steps in finding the difference. Step 1. Factor the denominator. Step 2. Find the LCD. Step 3. Make them equivalent expressions. Step 4. Subtract the numerator and keep the LCD. And step 5. Simplify if possible. For you to understand, here's an example. 5 over 2x squared plus 5x minus 3 subtracted to 3 over 2x squared minus 11x plus 5. The first step is to factor the denominators. As you can see, the denominators are general trinomials in which a is not equal to 1. So if you factor this, the outcome will be 5 over x plus 3 times 2x minus 1 subtracted to 3 over x minus 5 times 2x minus 1. The second step is to find the LCD. Once again, we have to align the common factors in order to find the LCD, and the outcome will be this. After that, we bring down the factors, and that leads us to x plus 3 times 2x minus 1 times x minus 5. That is the LCD. The third step is to make them equivalent fractions or expressions. To make them equivalent expressions, we have to check what both denominators don't have compared to the LCD. As you can see, the minuend's denominator doesn't have x minus 5. So in order to make it an equivalent expression, we have to multiply x minus 5 to the denominator and the numerator. We do the same to the subtrahend. In this case, however, the subtrahend's denominator doesn't have x plus 3. So we need to multiply it to both the denominator and the numerator in order to make the expression equivalent. When we rewrite the expression, we'd have 5 times x minus 5 subtracted to 3 times x plus 3 over the LCD x plus 3 times 2x minus 1 times x minus 5. The fourth step is to subtract the numerators and keep the LCD. Now before we subtract the numerators, let's distribute the terms outside the parentheses to the terms inside the parentheses first. Meaning, we have to distribute 5 to x minus 5 and negative 3 to x plus 3. Now we have to remember, when we distribute the term of the subtrahend to the terms inside the parentheses, we have to include the negative sign as well. That's why 3 became negative 3. The outcome will be like this. The last step is to simplify if possible. We can simplify this expression by combining the like terms. The like terms here are 5x and negative 3x. If we subtract this, we'd attain 2x. And we also have negative 25 and negative 9. If we add this, we'd get negative 34. Therefore, the final answer is 2x minus 34 over the LCD x plus 3 times 2x minus 1 times x minus 5.
To test if you understood the lesson, pause this video and try answering this equation. We'll show you the answer by the end of the video.